Hi, my name is Mr. Chu and I welcome you to my study room. Today's study is going to be about the use of algebra tiles, and we are going to use an application called Mathgon. Right, let's get onto the computer. So in your browser, type polypad.org. And it brings you straight onto the Mathgon interface. Or if you search Mathgon straight, then you are coming to click on algebra and it gives you the algebra tile. So someone may ask, what is an algebra tile? Algebra tiles are multicolored squares and rectangles that are used to represent algebra. We have small square tiles that represent 1 unit or the figure 1, and also rectangular tiles for the value of x. We also have a larger square to represent x squared. X squared tile is a square with a side length x. So you can see that when you bring the x tile against the x squared tile, it fits exactly onto the length and also onto the width. So it is the side x by x that gives us the x squared. And today I'm going to talk only about the unit tiles, the x and the x squared. I will not talk about yxy or y squares since I am not using them today. And these tiles, you can get it from any bookshop you go to. Say you want to buy algebra tiles, they are going to give you a set of tiles that you can use for your mathematical calculations like we'll be doing today. But then if you don't have the physical algebra tiles, you just get onto the Mathgon platform and then you have the virtual tiles to use like I'll be doing today. Now let's speak about the colors. For the algebra tile, we have 3 main different colors depending on how your tiles look like. So in my case, it's an orange color for the unit tiles, green color for the rectangular tiles, and a blue for the square tiles. But then from the physical algebraic tiles from the market, each of them has 2 colors. The main color, and when you turn the back or flip each tile, the color of the back is red, which has a negative value. So in our case here, because it is virtual, it's not been designed to flip over. So this is the negative x squared tile, which is the back of this one in the physical condition, and then this is negative x tile, which is supposed to be the back of the green tile, and then this is the negative 1 tile, which is also just the back of the orange tile. So when you get the actual algebraic tile from the market, the unit tile has its own color, and in this case is orange, and when you flip the back you get the red, which is negative 1. Then the x or the rectangular tile has its own color, in this case is green, and when you flip the back you get a red color, which is negative x. And then the square tile, which is blue, in this case having an x squared value, and when you flip the back you get a negative x squared. When you combine each pair you get a 0 pair, meaning it gives you 0. X squared plus negative x squared will give us 0, x plus negative x will give us 0, and 1 minus 1 or plus negative 1 will give us 0. So that is a 0 pair. When you combine any tile and its negative, you get a 0, and we'll be applying that later in today's lesson. Let's go deeper into the lesson by using some of these tiles to do some of the things. And the first thing we'll be doing will be to use the algebra tile for basic algebra. Right, so we can combine these tiles here to model any algebraic expression. So for example, let's model 2x plus 5. 2x plus 5 will be 2 of the x tiles, and then 5 unit tiles. Yeah, so that is 2x plus 5. Then we can also have, let's say, a quadratic expression like 3x squared plus 5x minus 3. So we're going to have 3 of the x squared. Right, so here we have 3x squared plus 5x minus 3. And you can try more examples for yourself. Just make sure that you use the red tiles for the negative values and the other colors for the positive values. Apart from combining these tiles to model basic algebraic expression, we can also use these tiles to solve one-step equations, and let's try that. Right, so let's solve one-step equation like 4x equals 12. This is how we use algebra tiles to solve this. We first draw a horizontal line under our equation, then a vertical line under the equal to sign, and then the next thing will be to use the algebra tiles to model each side of the vertical line. So let's do that quickly. Right, so we have the model of 4x being equal to 12. Our main aim of solving this equation is to get the value of x. So let's separate the 4x into single x's and divide the unit tiles among the x. Right, so by dividing them, each x has 3 units. So we say that therefore x equals 3. And we can try this for any one-step equation, but then I will try another one for a multi-step equation. Yeah, let's take an equation like 3x minus 3 equals 3. We're solving for x. So we'll be doing the same thing we did for the first one. We first draw a horizontal line, then a vertical one under the equal to sign. Then we model the equation using the tiles. 3x minus 3 equals 3. Then in solving using the balancing method, we have to move this negative 3 here so that we have only the 3x at one side and we solve for x. So that is exactly what we are going to do with the tiles. We remove this negative 3 by forming a 0 pair. That is by what? Adding positive 3. Then that will move the negative 3. Right, so we bring the 3 to cancel out the negative 3. But then in balancing, whatever we do to the left side, we do the same thing to the right side, right? So let's add this 3 we added to the left side also to the right side. So we have this here. Right. So immediately we add this 3 to the negative 3. They cancel out and we'll have 0. So let's eliminate that. And then now we have 3x being equal to 6. And we are solving for the value of x. So let's share the 6 unit among the 3x. And each of them is going to have 2 tiles. So that means that x equals 2 when 3x minus 3 equals 3. And again, you can try other examples by yourself. Just be very sure to introduce the opposite sign of whatever number you have there to both sides to balance it and also cancel out opposite colors. We can also use algebra tiles to work with signed numbers. So let's say we are adding positive 4 and negative 6. And remember here we are using only the single tiles because we don't have any x. So here we have our 4 orange tiles and then 6 red tiles representing -6, and the 4 positive tiles will cancel our 4 negative tiles to give us a 0, and we are now left with 2 negative tiles. Therefore our answer is -2. And we can also use subtraction for the same numbers. Let's try that and see. With this particular scenario, there are 2 ways we can solve this using the algebra tiles. The first option will be the fact that the negative here gives us a positive, so we take 4 positive tiles plus 6 positive tiles, and we'll put all together to give us 10 tiles. Then I spoke about 2 ways of doing it, so let's try the second option here. Here we have our 4 tiles where we need to subtract -6 or 6 red tiles from here, but then we don't have red, so what do? We use the 0 pair property. So we're going to have, in this case, we have our 4 positive tiles and we have to subtract 6 negative tiles from it. But then because we don't have the 6 negative tiles here, we need to introduce a 0 pair, which is obtained by bringing 6 negative tiles and then 6 positive tiles. That will cancel out to give us 0. Then now we can go ahead and subtract 6 negative tiles from here, and we'll be left with 10 tiles. So our answer for both of them is 10, and any of the approaches is up to you to use the one that you are very comfortable with, and this makes it more practical. Now let's try multiplication. For example, 3 times 4 is going to give us 3 groups of 4 tiles. And that gives us 12. So 3 times 4 equals 12. But in a case where we have our factor to be, say, -4, all we need to do will be to flip all our tiles to be 3 groups of -4 tiles, and that would simply give us -12. So that is it. And we can try similar thing for division. So let's say we have the reverse of that, where we have -12 divided by 4. So literally, I'm just going to pick this 12 here, duplicate it, and put it into 4 groups. I'm going to have 3 of them in each of the groups. So that is -12 divided by 4 is -3. And if the divisor is also negative, so let's say -12 divided by -4, then all we need to do is to flip each of them, and that gives us a +3. And you can work with your own examples for more understanding. We can also use algebra tiles to evaluate expressions. Let's say we decide to evaluate x squared minus x plus 2 when x equals 5. Starting from the far right here, we're going to model this by replacing the x with the 5. So we start with the 2, which doesn't have x. Then we have -x. Remember, x is 5, but this is -x, so we must have -5 tiles. Right, so we have our -x here, which is -5. then this is where we need to pay a little more attention. X squared just means we're going to form a square of side x units, which is the same in this case is 5. So a square of side 5 units. So let's do that quickly. Here we have our square with x units long and x unit wide. So that gives us x squared, which in this case x is 5. So after that, we combine all together. And remember, the opposite colors will cancel out. So this -4 will cancel out 4. Positive tiles, let me just put it on it, gives us 0. This also on it gives us 0. Alright, so these 5 tiles cancel out. I will have 22 tiles left. So that means this expression equals 22 when x equals 5. We can try another one. 2x squared plus 3x minus 5 when x equals 2. You can pause the video and try this one by yourself. Right, so we have our -5 here. We have 3 groups of 2 here. We have 2 groups of 2 squares. Remember, the x is 2, so x squared will be a square of length 2 and width 2, and we have 2 of those, so that's what we have here. So then again, this -5 will cancel out 5 of this to give us 0. We'll be left with 1. And adding it to this is 4, 8 plus 1, 9, gives us 9. So that means this expression here will give us 9 when x equals 2. And you can work out more examples by yourself. Algebra tiles can also be used to combine like terms. Let's try that. Using algebra tiles to combine like terms. So you have 2x squared plus 3x minus 5 plus x squared minus 7x plus 2. And as usual, we need to model each of them, then we combine like terms. So let's do that quickly. Yeah, so we have 2x squared plus 3x minus 5. Then x squared minus 7x plus 2. And now we are adding them. So we're going to combine tiles. Remember, different colors will cancel out. So this gives us 3x squared. Then 3 negative tiles will cancel out the 3 positive ones. And all these 3, because they amount to 0, they go away. And also these 2 will cancel 2 of the negative ones, and they also go away. I will now be left with 3x squared minus 4x minus 3 as our answer. We can use the same thing to do subtraction, and let's try one of that too. Right, so the same expression, but now subtraction instead of addition, and let's see how that goes. We have our actual representation, but because of this negative sign, we are going to negate the second expression. So just choose all of them, and then we negate and the sign changes. So now after negation, let's combine all colors, and these are different colors, so this and this will give us a 0, and we can safely remove that. Then we are left with x squared plus 10x minus 7, and that becomes our answer. And these are some of the basic things we can use algebra tiles to do, especially at the primary or elementary and middle school level, where we don't want to teach the concept in abstract. Then we can use algebra tiles. And again, remember, you can get algebra tiles in bookshops, where you can use if you don't want to use the virtual manipulatives. I hope this lesson has been of help to you. If yes, then kindly consider subscribing to this channel for more videos like this. Until we meet again, it's bye bye.